Welcome, Algebra students, to your first Unit 1 test review video. As you watch this video, feel free to fast forward if you understand something or go back and re-listen to anything that you may need help with. As I make this video, I will be looking at the study guide and I will be numbering as it is on the study guide. Let's take a look at number 1, which is the real number system. Thinking back to when we talked right now, think if you can make that graphic organizer on your own. If you know this graphic organizer and you understand it, you will have no problem with classifying numbers. Alright, let's go through. So we start with the real number system, and obviously we start with real numbers. Every number you see in this class is a real number. Okay, as soon as you get to Algebra 2, you will start to see imaginary numbers, and those are not real numbers. Underneath real numbers, a number can either be rational or it is irrational. It cannot be both. Rational numbers, there are a few different classifications under rational. They are integers, whole numbers, and counting. So let's start at the bottom with counting or natural numbers. Counting and natural numbers, think of when you were a baby and you first started to count. You started counting with 1, hopefully. Maybe you started with 0, but most babies start with the number 1. Okay, so these are whole numbers greater than 1, which means whole numbers, when we talk about the difference between counting and whole, is whole numbers include 0. So 0 is a whole number, however, it's not a counting or natural number. Okay. Integers, again, are going to include both whole and counting, however, they're also going to include negative numbers. So for example, -2, -1, 0 is in there, etc. Okay, so we can see if a number is counting, here at the bottom, it is also whole, it is an integer, it's rational, and it's real. So it kind of works its way up. If it's an integer, it's going to be rational and it's going to be real. If it's whole, it's going to be an integer, rational, and real. Okay, but I cannot go the opposite way. I can't go down on this graphic organizer and say a whole number is a counting number. That's true for most, like 1, 2, and 3. Remember, whole numbers include 0, so 0 is not a counting number. I also can't say integers, all integers are whole numbers, because again, I can see that I have negative numbers. Other numbers you'll see with real numbers within the rational category are fractions, terminating decimals, and repeating decimals. If we look at irrational, irrational are just messy decimals. They're going to be decimals that go on forever and have no pattern. Let's try classifying a few numbers. So let's look at the square root of 100. When you're given something to classify, make sure that you're classifying the simplified number. So right now, I want to look at what is the square root of 100, and I know that's 10. So now I'm classifying the number 10. The number 10, and I'm just going to go down my list, is real, it's rational, it's an integer, it's a whole number, and it's a counting number. So the number 10 has 5 different classifications. Another example is negative pi. We know that pi, yes, we can round it to -3.14. However, we know that it does not have an end, and it is not a repeating decimal. It's just kind of random numbers put together. There is no pattern that we see. So pi is still real, because again, every number we see in this class is real. However, it is irrational. Okay. The third example, let's classify the number 0. Okay, the number 0 is real, it's rational, it's an integer, and it is a whole number. Remember, it's not a counting number. Lastly, let's look at the square root of 17. We talked about perfect squares earlier this year. Perfect squares, an example of that is the square root of 100. 100 is a perfect square because when I take the square root of it, I get a whole number. If I were to take the square root of 17, I would not get a whole number. I would get a long decimal that never ends. So, I know this is real, but I also know that this is irrational. You can make it a rule of thumb of every non-perfect square is irrational. Alright, number 2 in your study guide is functions. So if we think back to functions, we've been talking about functions for a few years now, but in algebra we look at functions a little differently. Functions is a relationship that assigns exactly one output for every input. So if we think back of how we're used to talking about functions, okay, we could graph something and x is going to be our input, and if I plug an x value into, let's say, this equation, I would then get my y value. So if I plug in 0 to that equation, 2 times 0 is 0 plus 3, y would equal 3. X is my input because that's what I put into that equation. Y came out, so y is my output. Let's look at a few examples of how we can identify if it is a function or not. So if we look at our first example, and let's draw just a graph. 1, 2, 3, 4. 1, 2, 3, 4. And that's a little messy there, but let's graph 1, 1, 2, 2, 3, 3, and 4, 4. Okay, so I could make a straight line, and that's not perfectly straight, but you know what I'm talking about. And I could say I graph 1, 1, 2, 2, 3, 3, and 4, 4. So if I look back at the definition of a function that assigns exactly one output. So again, here we're looking, these are my outputs for every input. So I have exactly one number for every input. So yes, this would be a function. Let's look at another example. We're going to do the same thing. We're going to draw a graph. 1, 2, 3, 4. 1, 2, 3, 4. Keep making that one short. Okay. Let's graph 1, 1. We'll graph 1, 3, 2, 2, 3, 3, and 4, 4. So if I look at what I graphed, I did 1, 1, 1, 3, 2, 2, 3, 3, and 4, 4. Let's go back to our definition. Do we have exactly one output for every input? Here, if I look, I can locate the problem here, which are those two ordered pairs, 1, 1, and 1, 3. I don't have exactly one output for every input. For the input of 1, I see that I have both 1 and 3. That is impossible. I can't have something that's going to equal 1 and 3 at the same time. So right here on the graph would be the problem there. We can then conclude that this is not a function. Under functions, you also have some vocab terms such as independent and dependent variables. So when we're talking about graphing, we know that we can graph an independent and dependent variable. So what is the difference? If we look at the independent variable, okay, I know that I gave you that kind of rule of thumb that it almost works for everything, is what can you control? So think if you're independent, you're talking about yourself. What could you control within the situation? The dependent variable says it in its name. It's going to depend on whatever the independent variable is. Okay, so it's going to affect, the independent is going to affect what's going on with the dependent variable. Let's look at an example where we can identify each variable. So if I look at, let's just say we're talking about the high school 9th grade class size. Ooh, I don't know what I'm spelling there. Gotta erase that. 9th grade class size. Okay. And if we're given data and we're given the year, because it's going to change every year. And then we're given the number of students each year. Okay, so if I'm going to look to graph that, I know that on my graph, we talked about this being the independent variable on my x. Okay, some of you said the IX center. And then this is going to be your dependent on the y. The y depends on the x. So let's identify then, okay, what can I control? Well, in this case, I know that I really can't control what year it is, and I can't control the number of students. But I can pick out a year, and you know what? The number of students depends on the year. Okay, so in one year they may have 89, another year they may have 100. So I'm going to put down here, my year is my independent variable, and on my x would be the number of students, because the number of students depends on the year. Alright, we also talked about the domain and the range. So domain, a few words that I can associate with domain, remember, are my x values, my input values, and my independent, whatever that variable is. Some words I associate with range are my y values, the output, and the dependent variable. Okay, those are words that I can associate. So if I'm looking at the domain of something, I know that it's going to be talking about the x, and my range is going to be talking about the y. So in the last example, if you remember, my independent variable was the year. Okay, so if I had to give the domain, let's say it would be, I took data from 1988 to 2010. That would be my domain. Here, my range of that same example, my dependent variable was what? Number of students. So I would start with, okay, in 1988, how many students? Well, let's say, I don't know, there was 99. And then I would make kind of a range out of the range with, okay, in 2010, there was 113. So my range would be 99 through 113. The third concept on your study guide is scatter plots. When we discussed scatter plots, we talked about the three different types of correlation that we can see within a scatter plot. The first was a positive correlation. Okay. To remember this, we think about when one variable goes up or is increasing, the other variable goes up as well. A good example of positive correlation would be the amount of studying. So that could be measured in hours, minutes, and your test score or quiz score. So as you increase the time of studying, hopefully you'll see your test score is increasing as well. So we have two arrows going up, which would mean there's a positive correlation between the two. Second type of correlation is a negative correlation. We can show this using arrows as one variable is increasing, the other is decreasing. Good example for a negative correlation is the amount of free time you have and the number of classes you take. So if we look at this, we can see the amount, the increase of classes you take, the less free time you're going to have. So as one goes up, the other goes down. Lastly, there's no correlation. No correlation means that there is no, the variable does not depend on the other variable. So a good example would be maybe the weight of a baby and the hair color. Okay, if you look at those two variables, it does not matter, so it's not like if the baby's 7 pounds, it's going to have brown hair. There's no correlation between those two variables. The fourth concept on your study guide is a big concept dealing with equations and inequalities. In the second half of this unit, we talked a lot about writing equations and inequalities, solving them, and different special case equations that we could solve. For this, I'm not going to review any of these topics, but I will tell you on Schoology, I've posted several videos that talk about solving equations, distributive property, terms. Please let me know if you want me to post any other videos regarding these, but please check Schoology. There are videos posted regarding this. Another thing I would like to remind you is on the study guide under number 4, the last bullet point that says be able to create equations and inequalities to represent relationships and graph these equations. So I'll write this, number 4 on the study guide, the last bullet you may cross off. We did not get to that, so please cross out the last bullet or dash on the study guide. That will not be on your test. The last concept on your study guide is dimensional analysis. So let's take a look at how we would use dimensional analysis to convert 55 miles per hour to meters per minute. So the first thing we're always going to do is start off with what we're given. So we are given there are 55 miles for 1 hour. That's how fast that we are moving. So the next thing from here, we're going to set up multiple multiplication examples here, or problems I should say. We want to cancel out miles and get it to meters. We want to go from hours to minutes. So from this first step, it does not matter if we want to start with the distance or with my time factor. I like to just start with my time factor, get that out of the way. So I know I need to cancel out hours. I'm going to cancel out hours by putting hours on the top so that it can cancel. Conversion that will help me is 1 hour is 60 minutes. So from right off the bat, I can cancel out my hours. Currently, I have miles per minute. So I'm done with my time factor. I have what I want. I've gotten to minutes. So from here, let's start working with our distance factor. I have miles. I want to get to meters. So my first conversion, we're just looking for a conversion that we're given for miles. I know that in 1 mile, there's 5,280 feet. Now remember, you'll be given all of these different conversion factors, so no need to memorize any of these. From here, I know that my miles cancel. So currently, if I look at my rate, I'm given feet per minute. Well, I want meters per minute, so we're getting closer. Okay. I want to cancel out feet because I don't want feet anymore. Let's use another conversion with feet. I know that in 1 foot, there are 12 inches. So how does that help me? I know that I can cancel out feet, and I'm currently left with inches per minute. I want to get rid of inches. So what could help me get rid of inches? I know in 1 inch, there's 2.54 centimeters. From here, inches cancel. I'm now centimeters per minute. I'm getting closer. I need meters per minute. What will help me get meters? Well, I know that there are 100 centimeters in 1 meter. Centimeters will cancel. I'm left with meters per minute, which is what I want. So from here, I still have to now multiply. This is just like multiplying fractions. I'm going to multiply all the way across on the numerator and all the way across on the denominator. So on the top, it's going to be 55 times 1 times 5,280 times 12 times 2.54. And if I calculate that correct, we get 8851392. Okay. On the bottom, we're going to multiply 1 times 60 times 1 times 1 times 1 times 100, and we should get 6,000. From here, I'm going to divide, because I don't want to know per every 6,000 minutes. I want to know for 1 minute. So when I divide these two, I get 1,475.232, and I would always tell you how to round that on the test, meters per minute. So that would be your final answer there. That concludes your review video for your Unit 1 test. Please let me know if you have any questions. Good luck studying.